Just like 8.1.
So we'll see how it goes. See how it goes. But what we're looking at today is we're going to start with the binomial theorem.
That sounds
exciting, doesn't it?
Oh yeah. I'm on the edge of my seat, Mr. Washington.
See, I knew it.
He's like bouncing up and down.
That's what you guys come for. It's like, this is
Binomial theorem. My favorite.
All right, so in the expansion of, here's a binomial, x plus y. If we have x plus y raised to some power, you can think of it as x plus y like this. It'll follow this pattern here, x to the n. It doesn't matter what the power of n is. This right here will end up happening, where you have x to the n, then you have n times x to the n minus 1 times whatever the y value is, and it's going to go dot dot dot, and then you'll have some term in the middle here that looks like this.
That's so.
So it's this middle term that we're kind of focusing on. It's going to be the focus of this initial discussion. Plus, and then dot, dot, dot. You get down here to the end. This is really, the binomial theorem, the expansion of this binomial is expanding on the board. I didn't count on that happening. N, x, y,
This looks like a pain.
n minus 1 plus y n. All right.
Is that a plus or an X next to the N?
There's like 1,000 of those on there. Which one are you talking about?
Very end, the one you just wrote. Is that NXY?
N, x, y. Yeah.
And then to the N power.
N minus 1 to the n minus 1 power?
Yes.
Does that make sense?
Yes.
All right.
I don't know what these are, so I
All right, so like I said, we're focusing on this coefficient right here.
8 is a strong word.
So if you think about the way this works, let's just say this is x plus y to the third power.
Okay.
To keep it simple, right? So this is going to be x to the third, right here, right? This is going to be 3x times 3x with x to the square, x squared times a y. And then we're going to get this middle term here in the middle that we're going to talk about in a second. And then down here at the other end, you've got our n shows up again, so this is 3x times y squared, and then finally ends with y cubed, okay? Excuse me. So they always follow the same pattern, and the coefficient of x n minus r y to the r, this middle term here, is, we write that coefficient like this. N factorial, n minus r factorial times r factorial. So sometimes this portion here is written like this, the symbol n r is often used in place of NCR to denote binomial coefficients. So that's our definition for the binomial theorem, and I think once we start, this is just one of those you're going to have to start doing some problems, and it'll make more sense as we start working with it. Any other questions about anything I've written down that's unclear?
And all of it's unclear, so I mean, might as well just go on with
My writing, I'm talking specifically about my writing.
No.
All the X's and the R's and the N's and all that. All right, so let's do example 1. Do a couple of those. C8, 2. All right, so if we're asked to find this binomial coefficient, then what would we do based on our formula over there? We would say that means that this is 8 factorial, right? Over n minus r, 8 minus 2 is 6 factorial, times r factorial, which is 2 factorial, right? There it is. But since we're experts at factorials now, because we had a quiz on it, once you have a quiz on it, you basically become an expert.
Exactly.
Duh.
So what's going to cancel out here on top? We're just going to have 8 times 7, because that's 8 times 7 times 6 factorial, and that'll cancel out with this 6 factorial. And then on the bottom, we'll just have 2 times 1. Does everybody see that? How I got that? And then the number of 28. So recognize that the top here is 8 times 7 times 6, and we could say 6 factorial from that point on. And then we've got 6 factorial on the bottom, and 2 factorial is the same as 2 times 1. So these cancel out, and we're left with 8 times 7 over 2 times 1. Yes?
Where'd the 6 on the bottom come from?
This formula right here. N minus r factorial times r factorial. All right, so it's 8 minus 2.
Oh, I see.
Any other questions?
No.
Everybody clear? I was using this formula
Yes.
right here. Let me put a box around that.
So what's the long one on top for?
Huh?
You'll see in a second. You'll see in a second. This way.
Yeah, it's really just saying this is what, if we expand any binomial, it'll fit this pattern. And so if you expand the binomial, since it fits this pattern, you'll always end up with this binomial coefficient in the middle. So that's
So
what
we
we're
need to know
focused
how to
on.
find
What
the
is expanding?
coefficient.
What is expanding it accomplish?
What does expanding it accomplish?
Yeah,
Well, it gives you a quick way, because if you have something like x plus 2 to the 12th power,
Yeah.
you can't easily find that, right? That would be a pain to try to calculate that. So this
Yeah.
gives you a quicker way to find that. Does that make sense?
I guess so.
You guess.
I don't know. We're not at the part where we're using that formula yet. We're still using that a little.
But I'm just saying, you understand that would
Yeah,
be really
yeah.
hard, right?
Yeah.
So it'd be nice to have a
quick.
quicker way to do that.
Okay.
Right?
So it's a quicker way to do.
The expanding
worse
binomials.
Okay.
All right, got it? That's what this is all about. That's why we're going to talk about Pascal's triangle at the end, that you guys were really excited about hearing about. All right, so let's do another one. Let's see it written in a different form. 10 over 3. Right? So this is the same thing as 10C3. You could write it like that, right? Is that clear to everybody?
Yes.
Thank you, everybody. So we would have 10 factorial on the top, we would have 7 factorial here, and we would have 3 factorial here, right? So again, as you're doing this, the same kind of thing happens, right? We've got 10 times 9 times 8 times 7 factorial. So that'll cancel out with 7 factorial down here. This expands to be 3 times 2 times 1. So our final answer is 10 times 9 times 8 over 3 times 2 times 1. And that gives us 120. So we notice for both of these, you kind of start with this number up top, and you count down to the number just before, whatever this number is on bottom, right? Mm-hmm. And then you start with this number, so those go away, and then you start with these and count down from there. So that's sort of the pattern that you see in all of them. Oh, this is a good one, just to make sure that we remember how this works. What if I have this? So on the top I have 7 factorial, and then 7 factorial, and then 0 factorial, right?
It'd be 1. The 0 factorial would be 1.
That's what we have to remember. 0 factorial is not 0, it's 1.
It's 1.
If that had turned into 0, then we'd have an undefined.
Yes.
Right? So this just becomes 1.
Oh yeah, because
Because these cancel
Yeah,
out.
yeah,
You got
yeah.
one
Yeah, yeah,
on
I
the
see.
bottom,
Confident in it too. Like,
one on the top. And then similarly, if we had the same numbers like we have right here with 8 and 8, whoops, there's no division sign there, 8 and 8, that equals 8 factorial over 0 times 8 factorial. So 0 factorial. So again, that's going to be 1 over 1, which equals 1. So if we have a second number of 0, or if we have the same number for both, we're always going to get 1.
Why is 0 factorial equal to 1? Because if you do like 0 times 0, it equals 0. Because every number you spread out, and so like 5 would be 1 times 2 times 3 times 4
It
times
just
5.
has to do with the definition of a factorial. You know, the definition of a factorial always ends in 1.
Yeah.
So they made, some really smart person made a decision that, well, 0
Zero
factorial
factorial
should be
is
0 because it has to
stupid.
end in 1. So
0
we're gonna
does not
say,
equal 1. 0 does not equal 1. I feel like that's just like a
Yeah.
stupid person.
there's not
saying-
0 equals 1, we're saying 0 factorial
So
equals
then
1.
I feel like 0 factorial just shouldn't exist if you're gonna say equals 1. Because 1 factorial equals 1, and then 0 factorial.
You're gonna have to talk to that really smart person, but let me warn you, he's
I doubt
probably,
he's really
he's probably
smart.
dead. All right?
I doubt he's a really smart person. He could, I would have killed him.
Oh my god.
Can't.
All right. Any questions about how to do those?
No.
All right. We saw the pattern emerge,
Yeah.
right? So it says let's do one, just using a pattern. So if we have 12, C, 11, right? Our pattern is we take the top part and we start multiplying until we get to this number. So it just stays 12, right? And then we start wherever this number is, and we go down from there. So this would be,
Never.
You want to say something?
No, I was trying to think like which one.
Do you want to share? You want to share what you've got in the whole class?
No. No, I don't.
This is actually
Okay.
the better one would have been to do this one first. Sorry.
Go on.
But let's go ahead and do this one because we've already started it. So if we do that, we've got a 1 factorial here. This is 12 times 11 factorial, and then we've got 11 factorial here. So those cancel out. So it's just 12 over 1, which is 12. The one that's more, so we count down. So the other one is 12C1 like this. So we have 12 on the top.
And 1 on the bottom.
So that's 12 factorial over 11 factorial and 1 factorial. Right? So that becomes 12 over 1 also.
Equals 12. Whoa.
I'm just trying to figure out why I did that.
Me too. Me too.
You don't ask questions, you just do.
You're the one who just answered the 0 factorial. I told you not to ask the question.
I don't see how the pattern is helping us.
That's what I'm saying.
No.
It's like,
It isn't.
well, it's just not, right? It's not helping us at all.
What did it do? Nothing.
So, anyway, you're just going to have to do it like this and figure out what cancels out.
Well, because it's 12 times 11 times 10, right? And then and then on the bottom is 11 factorial.
Yeah, I mean, if I don't write it like this, I was looking at how these worked out, right? Where we always went 8, 7, 6,
Well, 1 makes everything weird. One,
and then we
one
did
and 2
2,
make
1.
everything weird.
Yeah, but this right here,
Well, all that happened was the 11 factorial canceled out with all the 12 factorial except for 12, and then it leaves 1 factorial and 12.
right?
So you get 12 over 1, which equals 12.
Yeah, this thinking about the pattern that we saw here didn't really help us simplify this one. It's easier to just kind of stick with the factorial. So I think it's going to be just be important to recognize.
Just
Hey, don't ask questions, just do the math.
exactly.
Yeah, just do that. So let's make sure, let's do one more and make sure we got it. 7 over 4. So that's going to be 7 factorial on top, 3 factorial here, and then 4 factorial there. So yeah, that we know this is going to 7, 6, 5 times 4 factorial, right? And then this is going to be, we could say 3 factorial is just going to be 6. And we've got 4 factorial here, so this will cancel out, this 6 will cancel out, so we're left with 35. That one. So I think you're just going to have to punch them in and see.
Wait, how did we get 35 if the 6 if everything on the bottom canceled out? Oh, it was
So
just
7 times 5 is 35,
oh, it's just 7 and 5 left?
right? Our 3 factorial canceled out with 6 on top. So just because they're just numbers, right? 3 times 2 times 1 is 6,
yeah.
right?
I get that.
Oh, you did the.
That
You just
makes
did the
sense.
factorial of 3 instead. Okay.
Yeah,
Yeah,
I
I
multiplied
was-
that.
Yeah, that took me a second. I was like,
Yeah.
No, that makes sense.
But this is a good example because it shows you that sometimes more than just the factorial will cancel out
Yeah.
once you expand it out.
you have to write everything out.
Just do the math and don't ask questions.
Do the math. Do the math. All right.
That's not on the-
Any questions about that?
No.
No.
Good.
Just
So then let's actually expand a binomial,
No,
which is
we can
what the
skip
benefit is of learning this concept, right? So let's actually try that. Nobody has any questions? Seriously? I mean, this is going to be on the quiz next week, so I do want to make sure that you understand what I'm doing.
I feel like this.
sorry, Steven, if you're watching this.
Yeah, Steven, sorry. It's gonna suck for you.
Okay. So, example number 3 tells us to write the expansion of x plus 1 cubed. Okay? And so the first thing that we're going to do then is we're going to find the binomial coefficients. So here's what the binomial coefficients would be. We start with the 3 because it's raised to the 3rd power. And then we take these guys and we go 3, 1 and 3, 2 and 3, 3. Those would be our binomial coefficients. And so if we calculate each of those guys, see, I wish they would tell me how to read this because I don't know how to say it.
3c to 0.
3C, 0.
But hopefully we've done enough at this point to where we can just kind of calculate this in our head. Right, so we got a 3 factorial on the top, a 3 factorial on the bottom, and a 1. So this is just going to be 1. Does everybody see that?
Mm-hmm.
I tell you what, I'll take the one extra step and just write it down. So this would be 3 factorial on top. 3 minus 0 is 3 factorial here, and then this is 0 factorial. So that's going to turn out to be 1 because these cancel out, right? This is going to be 3 factorial on top. This is going to be 2 factorial right here, and then a 1 factorial. So we'll have 3 over 1. That's going to be 3 altogether. 3 factorial here, 1 factorial here, and a 2 factorial there. So that's also going to be a 3. And then finally, 3 factorial here, 0 factorial here, and 3 factorial there. And so that gives us 1. So that tells us what our coefficients are going to be for each of these guys. So it's going to be 1 times x cubed plus 3 times x squared times 1 plus 3 times x times 1 squared plus 1 times 1 cubed. So simplifying that, we get x cubed plus 3x squared plus 3x plus 1. And that's our final answer.
Yeah, that's definitely way easier.
So what it allowed us to do, just to make sure that everybody's following what we did there, we started with we had to figure out our coefficients first, right? And then we had to do this according to the pattern that we have right here. So we had x cubed. Start with just the first term that's in our binomial. We raise it to whatever the power is. Then the next time we have x, but it goes down 1 power. So in each term it's going to go down 1. X squared here, x1 here, finally x0 here totally goes away, right? The 1 is not in this term at all, but it's going to go up each time. So this is 1 to the first power, 1 to the second power, and finally 1 cubed to get all the way to the end. And then you just plug these coefficients in front of it and simplify. So that's the method for doing this, rather than trying to do FOIL multiple times or.
So point, where are the coefficients in like the definition we do? Where is the coefficients? Is that the C right there?
Yes. The
That's the s-
binomial coefficients.
And
is
the
the C.
in the expansion of the binomial of x plus y to the n, those coefficients are where C is, right? Yes, no.
This right here.
Is that where the coefficients go?
That's the coefficient. Yeah, I kind of wish they would have. I guess they just wanted to write it out like this and show us that there is a coefficient. I wish they would have done this. I wish they would have actually put C, maybe C in 0 right there. So we would have seen that. And then this would be C in 1, right?
Mm-hmm.
So that we could have made sense of that as we went along. They kind of throw this in here, and it's like, well, that's confusing. I didn't see that coming out of this, right? But this is sort of understood to be the case in the way that they've written this out. Until you get all the way over here where you've got C, C in N, right?
Mm-hmm.
But once you do the problem, that makes sense how we did that, right?
Yes. A little bit.
Right. Now there is a difference whenever you do differences. There's a difference when you do differences. So if we had x minus 1 instead of x plus 1, our answer would have been exactly the same, but you have to alternate signs. So it would have just been that. So whatever our first answer was, you just write down the first answer and then alternate signs all the way through. And that would be clear if we worked it out, because we'd see that this term is a -1, right? So this becomes a -1 here, a -1 here. The square will get rid of the negative there, but the cube will keep the negative in there. So that's why it alternates when that second term is negative. All right, do you guys think you have that down? Is there any need for me to do example 5? I only wrote down to do 5a. Let's do that one because it is a little more complicated. Just to make sure you guys are all tracking with me. Um, 2x minus 3 raised to the 4th power. All right, so we've got to calculate, for this problem here, we've got to calculate for 0, for 1, for 2, for 3, and then finally for 4, right? And so our coefficient for these, we're always going to have 1 for this and 1 for this. You guys see how that's always going to work out with our coefficients?
Yes.
And so this one there is 4 factorial over 3 factorial. So as it turns out, this one's always going to be whatever our first term is, and this is always going to be our first term.
So now it's just the middle one.
So it's really the one in the middle, right, for this one here, that's going to be the more complicated one. So 4 factorial over 2 factorial times 2 factorial. So that's 4 times 3 over 2. So that just becomes 6. Is that right? Yep. So then if we expand this guy, we're going to have our so 2x minus 3 to the 4th. We'll have our x in the front, our coefficient in the front, so 1, and then we'll have 2x to the 4th power. Our next one will have 4, and we'll have 2x to the 3rd power, but now our other term is going to be introduced. So there's our -3 to the 1st power. And then we'll have 6 times 2x squared with a negative 3 to the second power, and then we'll have a 4 times 2x to the first power with a negative 3 to the third power, and then finally 2x disappears in this term, and we've got just negative 3 raised to the fourth power. Did I lose anybody when I wrote that step down? Does that make sense?
Yes. So,
All right. Did you say sort of?
yeah. It does just take time to do it. I mean, it's
Yeah, it does take time, but it's sort of making sense is different from
yeah.
it takes time. So does it make sense, and you just,
Yes, I
you just gotta
understand,
take the time to do it.
Understand where the it's not that I didn't understand it before. It's like I didn't know where the numbers went, but like after seeing like it with numbers.
Do an example,
numbers,
right?
Like, makes
Yeah,
sense.
yeah. Diego?
So what is 2x and that is 2x x in the formula?
In our formula, this is x, and this is y, right? X equals 2x, y equals negative 3 in this original formula. Make sense? And so you can see here, because we have a negative number that's raised to these powers, right? This sign here will become a negative sign, and this sign here is going to be a negative sign.
What's in?
N is 4.
So on that first one where it's like 1 times 2x to the 4, it's
Uh-huh.
always an imaginary negative 3 to the 0, right?
That's right.
Okay.
Yeah. So if you did the math on all this, you'd come up with 16x to the fourth minus 96x cubed plus 216x squared minus 216x plus 81. So that would be the final answer. All right, questions about that? Could you guys expand this if I gave it to you on the test? No quiz?
Yeah, it's definitely, yeah.
Okay, yeah, all right, I like it. Now what if I asked you to find a specific term? So how do we find a specific term?
Oh my goodness, Mr. Walker, you're asking a lot of me now.
I think expanding it was enough.
Let's say that there's actually a simple formula for that. So to find I want to write this. Find a specific term for x plus y to the n. Use n r, which is 1 less than n in this formula. N C r x n minus r y to the r. That's the formula we will use. So if, for example, we had x squared plus 4 cubed. And we were asked to find third term. Okay? And plugging that into our formula, we use 3 for n. And we use 1 less than that for the r, so that would be 2, sorry. 2, and then finally x squared (3 minus 2 times 4 squared). So do you see how I plug those numbers in?
Can you do that one more time? Sorry, I missed the first part.
It's okay. So we were asked to find the third term, right? So we take this formula here.
Okay.
We plug in 3 for n,
Got it.
right? R is 1 less than that value, so R becomes 2. Our x term is x squared in this particular one, so n minus r is 3 minus 2, so that's 1. And then 4 squared, since that's the r. All right, so that would be the c for this would be 3 factorial over 1 factorial times 2 factorial. So it's just going to be 3, right? So this final value here would be 3. This was x, just x squared times 16. And so that's what, 48 x squared? 48 x squared would be our third term. Make sense? Mm-hmm. Let's do one more like that, just to make sure that we've got. Let's find the sixth term of a. Just make some room here. A plus 2b raised to the 8th power. So we plug in all of our values from that where, okay, wait just a second, sorry. All right, yeah, why does that say is 1 less than n?
It's supposed to be 1 less than the term.
Yeah, it's 1 less than whatever one we're finding. So where's that formula in our book where r plus 1 term? Yeah, it shouldn't be 1 less than n, I'm sorry. This was confusing because the 3 is the n and we're trying to find the third term. Find a specific term for this, use r, which is 1 less than the term you're finding. Sorry about that, guys. Because I was looking at this going, well, if that's the case, then this will always be 1 right here. But I don't think that's so. And it's not. So they give us this one and say find the 6th term. So the r in this case is going to be 5 because r is 1 less than the term that we're trying to find.
Okay.
N is 8, just like it is over here.
Okay.
Right? That makes sense. So now we've got C. Looking at our formula, I want to write our formula down, and we're going to plug in all our values to make sure we're all on the same page. So n again is taken directly from this, right? So let's identify our values. N is equal to 8. R is 1 less than the term we're trying to find, so R is 6 minus 1, or 5. Right? X in this particular example is A.
So the 8 to the 8?
And then Y is 2B.
Uh-huh.
So everybody see that?
Yes.
All right. So now if we just plug that in, C, 8, 5,
8 to the
A to the N minus R, 8 minus 5, which is 3. And then Y is 2B to the R, which is 5. So it looks like that. This is going to be 8 factorial over 3 factorial times 5 factorial. So 876. over 6. Right, so 8 times 7, which is 56. This over here. And so, what's 2 to the 5th? 32?
Yeah.
Is that right? So then we've got this value here is 56 a cubed times 32 b to the 5th. And then whatever big number that is on the front there, 1792 a cubed b to the 5th. That would be our answer. Any questions about that? It's just plug and play. You just have to you have to make sure you identify the numbers correctly. All right, I'm not going to do example 7b. But note, if you look in your book at 7b, it's finding the coefficient of the term a6 b5 in the expansion of this. So they don't tell us the 6th or the 7th term. They say the a6 b5 term.
Wait, where on 7b?
7b, you guys see that? And so what they're noting is it's always the r plus 1th term, and so in this case here, how do we know that r is 5? Everybody know? Anybody tell me? Yeah, you got it, Diego?
Like, because b to the 5th power?
Because in the formula it has a y to the y is wherever has it's y to the r, and that is b to the 5. So then the
B to the 5
is what we're finding.
Yeah, right. Because if it's b to the 6, if you look at it how they work it out down there, if b is 5. I'm sorry, if r is 5, then we'll have b to the 5th as our term, right? They're trying to find a term where b is to the 5th power.
And then we can do it 11c5.
And so you can think about it like that, right? Since we've got 2a is what x is equal to, and b is equal to 5b. So we know that when we plug this guy in here, we're going to have, it's going to end up with a being to the 6th power and b to the 5th power. Right, and the only way that those numbers are going to work out for us is if we have an r that's equal to 5. Does everybody see that? So that's how we can determine which r we're going to use for that one. All right, I know we're about out of time, so I want to do Pascal's triangle. But did I lose anybody when I did this? I mean, I guess another way you can think about it is you know that this guy starts with a power of 11. On the first term, the x term, the a term, and so you can say, well, 11, and if I count down, I've got to get to somewhere where my value has to be a to the 6. So 11, 10, 9, 8, 7, 6. That would be my 6th term when I count down and I get an a to the 6th power. So you could think of it that way as well, but I think this is probably the more obvious way. All right, what does Pascal's triangle look like? Has anybody ever heard of Blaise Pascal? Or it's probably like Blase or something like that. He's French. You know how that's French now. Anybody ever heard of him?
No.
Really? Man, I know Diego's heard of him. He should have heard of him because Diego took my chemistry class.
Oh.
And one of our units for pressure was the Pascal.
Oh, yeah.
And so Pascal was a French mathematician, he was a scientist, but he was also a philosopher. He was a Christian. And so he's got some really cool sayings that, like there's something called Pascal's wager. If you look that up, you can kind of see the exact wording of it. But the two sayings, and one of these is Pascal's wager. I can't remember. I think Pascal's wager sort of goes like this, and I'm gonna paraphrase, but it's kind of like, all right, if you say you don't believe in God, and I do believe in God, all right, when we get to the end of the road and we finally die, you're saying we just die and then there's nothing more, right? I'm saying that there's an eternity and there's a God that we want to be in good standing with, and that good standing is found in Jesus Christ. That's what this God has revealed to us. So let's say I live my life and I serve the Lord and I die to self and I do all the things that Christ says it means to be his disciple, right? I trust in him. That's number one. You confess your sins and you believe in the Lord Jesus Christ, right? And then I live according to that. Well, maybe I didn't have as good of a life here as you did, but you know what? When I'm dead, what does it matter? I'm dead and gone. It doesn't matter. But let's say you live it up and you ignore what God has said in his word, and then you hit eternity and you do meet God. And hell turns out to be real, and there are actually consequences for your sins eternally, and so that's your experience for the rest of your life. You know, if you're gambling on that, which one's really the better wager of the two? And that was kind of the proposal that he made, I think that's called Pascal's wager. But he's also the guy, if you've ever heard someone say everybody has a God-shaped hole in them. That's not really how he phrased it, but his point is that all of us, because we were made in God's image and God made us for relationship with him, all of us are missing that relationship. And so we're born that way, and that's why man just in general will worship something. There's an old Bob Dylan song that says you got to serve somebody. And it's like, it may be the devil or it might be the Lord, but you're going to serve somebody. And he lists like all these other things. We're going to give ourselves to something. Something's going to be our idol and kind of be functioning as our God. And Pascal said that's because when man fell in the garden, we lost that relationship. We lost that fellowship. And we're longing for that. But the sad thing is man tries to replace it with all these other things when God says very clearly in his word, you're only going to find that satisfaction in Jesus Christ. So Pascal's kind of a cool guy, and he's given us, there was a computer language, one of the first computer languages I ever learned was by Pascal. But this is his triangle. And his triangle was written like this. Starts with this 1 at the top, and as you go down the triangle, you just sum the numbers that are above. You know, so 1 plus 2 is 3. So we just sum the numbers that we wrote on the previous line. And so they look like this: 6, 4, 1, and then 1, 5, 10, 10, 5, 1, and 1, 6, 15, 20. I'm just adding them up, right? 6, 1, and then finally, if I do this row here, 7, 21, 35, 35, 21, 7, 1. And we can keep going. And so this is row 0 at the top, and this is row 1, and this is row 2, all the way down until we get to row 7 down here. And we can keep going. And so we can use Pascal's triangle to do problems like example number 8, where it says use the 7th row of Pascal's triangle to find the binomial coefficients, and it lists out the coefficients 8, and then 8, 1, and then 8, 2. So I should have stopped here, actually, right? Because I think that's the triangle they give us in the book, and they say, what are the coefficients? What are the next coefficients? Actually use the 7th row to find, yeah, I did that right. 1, 7, 21, 35, 35, 21, 7, 1. And so for finding this one, we're going to 8. So we actually need the 8th row to figure out what the coefficients are for this, right? And so it's straightforward enough, but this would be, for our 8th row, this term here would be 1 plus 7, which is going to be 8. And this term here would be 7 plus 21, which is going to be 28. And this term here would be 21 plus 35, which is going to be 56, and so on, right? And so we could list, I told you guys wrong, I'm sorry. Sorry, I forgot there's a 1 in the front. So let's change this to C8, 0, 1, 2, 3. There we go. So there's a 1 first. 1, 8, 28, 56. So that would be our coefficient. So what that means is that if we had this right here, x plus y to the 8th power, then that particular equation would look like x to the 8th with this coefficient, and then the next one would be 8, x7, y, and then the next one would be plus 28, x to the 6th, y squared, plus 56, x to the 5th, y cubed, dot, 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 right? You would just keep going using Pascal's triangle. So it's just a kind of maybe a quicker way if it's not, you know, if it's not too many rows down, you could just use Pascal's triangle to figure out the coefficients like that. Okay? All right, we're a little bit over. Sorry, you guys have to eat your lunch quickly. You guys have a great. Everybody tell Stephen hi.
Hi, Stephen.
Hi, Stephen. Missed you in class, buddy. And y'all have a good day.